In today's video, we'll build joint 1 of the LeRobot SO101 follower arm and make it move following your command. Joint 1 is the shoulder pan joint at the base of the robot. This will be the first time you control a robotic arm. For this build, you'll need motor F1, the 3D printed follower base, the base motor holder, the rotational pitch component, 2 motor horns, the horn screw, the required mounting screws, a servo cable, the wave share board, its power supply, and a USB cable for connecting the board to your Mac. Keep the other 5 motors out of the way for now. We only need F1 in this episode. Start with the follower base and motor F1. Use the official SO101 assembly animation shown on screen to check the correct orientation of the motor. Slide F1 into the motor slot in the base and attach the motor holder. Make sure the motor is completely seated and facing the same direction as the animation. Keep the servo connector accessible and make sure nothing is trapped between the motor and the printed plastic. Next, install the motor horns. Place 1 horn on each side of F1. The splined horn goes onto the gold output gear, while the other horn goes onto the opposite side of the motor. Secure the horn on the gold output gear using the horn screw. Check that both horns are sitting flat and are fully seated before continuing. When you're finished, F1 should be secure and should not move around inside the base. Next, attach the rotational pitch component. Position it between the motor horns, matching the orientation shown in the SO101 animation. Align the mounting holes and install the screws on both sides. Start the screws before fully tightening them so the component stays centered. Once it is secure, check that the part sits evenly and has enough clearance to move. At this point, the mechanical assembly of joint 1 is complete. Before we test the joint, connect the servo cable to any one of the cable slots in F1 and the other end to the wave share board using the servo cable. Then connect the wave share board to its power supply and connect the board to your Mac using USB. If your Mac only has USB-C ports, use a USB hub or adapter. Keep the area around joint 1 clear before applying power, and make sure the cable has enough slack to move without being pulled or pinched. Now we have arrived at the software part. We will install PhosphoBot. PhosphoBot is an open-source robotics application that supports the SO101 and gives us an easy way to check that our hardware is communicating with the computer. Open the PhosphoBot installation guide linked in the description and follow the macOS installation instructions shown on screen. Once installation is complete, open Terminal and run PhosphoBot run. Wait for the server to start, then open your browser and go to localhost to open the PhosphoBot dashboard. In the PhosphoBot dashboard, check that the connected SO101 hardware is detected without a communication error. We simply want to confirm that F1, the wave share board, and the Mac can communicate correctly before we build the rest of the arm. You can make one very small shoulder pan movement as an additional test. To do this, in the PhosphoBot dashboard, click the big control button. Inside the control, click Start Keyboard Control. Once it starts up, use the left arrow to verify that it moves. It will only move a tiny bit because we have not gone through the more complex full arm calibration, and we will do that in one of the later videos. If it works, then congratulations! You've now built joint 1 of the SO101 follower and confirmed that the basic hardware connection is working. In the next video, we'll continue from this assembly and build the remaining joints of the follower arm.